Alright, today we're going to do Tutorial A, which is an introduction to Visual Studio and C#. I'm assuming you've installed Visual Studio. I know you're using a later version, most likely, than I am, which is 2013. That's okay, hopefully it's not too different. So if you go in the folder, you'll see two documents, PDF or Word doc, whichever one you like. I think I'll grab the PDF. I'm going to kind of dock it on the side so that I know I'm not going to be able to keep everything on the screen all at once. You're going to need to just open this yourself rather than try to, read it on the screen. On the other hand, hopefully from the video you'll be able to follow along without even looking at it. But if you get stuck, check the documentation. Alright, what are we going to do? We're going to open a new project, a C# project. So we're going to go to New Project. And we're not doing C++, we're doing Visual C#. And what we want is a console application. So I'm going to choose console application. And if you've done Windows programming or Java programming or Python programming, you know what a console application is. It doesn't have nice GUIs and drop-down menus and stuff like that. It's just scrolling text on a screen. Okay, there's a few things that we want to do to kind of make our development environment a little bit better. Let's get the build and the debug menu out if they are not already out there. So up here on the toolbar, right click on your menu bar, on your toolbar, and choose build. And you'll see a couple new buttons pop up there. Drag that over onto the next row so it's super easy to find. I'll zoom in on this when we're actually going to edit some text. Then do the same thing, right click on debug. The debug menu will pop up. Go and drag this next to the build menu. Build toolbar. There we go. We're not going to use hardly any of these today, but we will use one of the buttons. We will do build solution. The application kind of interchangeably uses the terms solution and project. So if I call it a project and the menu option says solution, please just understand that they're the same thing. Notice that we did file new project rather than file new solution. So they're inconsistent as well. Okay, one more thing we want to do maybe is to enable line numbers. To do that, we're going to go into Tools, Options, scroll down to Text Editor. From Text Editor, we're going to choose General. Or is it all languages? Yes, we're going to choose Text Editor, all languages, and then there's a checkbox for line numbers. Do you need that? Nah. Is it useful? Yeah, I think it is so. I think so. I like seeing the line numbers. There we go. All right, let's check our document, see where we need to be. Okay, we've done the customized Visual Studio. We need to make sure the Solution Explorer is visible. If you load it up and it kind of looks like this without Solution Explorer visible, that's a problem. If that's the case, go up to View, Solution Explorer. Then the Solution Explorer is back. We're back in the saddle. Alright, why do we need this? This is where we can change the preferences for our program. We can go, and if we have more than one file, we can toggle between them. Right now we only have one file, program.cs, CS standing for C#. But we want to make one more change. We're going to add some command line arguments to our debugging. What are command line arguments? Well, if you have a command line program, like if I type dir, great, it does some directory, but I can type in additional commands to control how dir works. For example, if I want to sort things by date, I can do dir/od. That's what's known as a command line argument. I think I was just calling it a command line parameter. Both terms are used. Argument is the correct term as far as this editing user interface is called. So let's add some. We're going to come over here to Console Application 1, right click on that bold line under Solution Explorer, choose Properties. We need to find the Debug tab. I don't see what I'm looking for here, so I'm going to go back to my instructions. Under Debug, we should see Start Options, Command Line Parameters. Oh, it's right there. Excuse me, Command Line Arguments. Okay, so Debug, Start Options, Command Line Argument. Now, I don't really care what you type in as long as it has a phrase in quotes. My instructions say, Jar Jar Binks, end quote, is the best, quote, in a beginning quote, Star Wars character. And I know that's really small print, but what it says is, quote, Jar Jar Binks, end quote, is the best, beginning quote, Star Wars, end quote, character. I just want you to have like 2 words or more that are enclosed in a pair of quotes, double quotes, so that you can see what it looks like when it runs. Alrighty, kind of done with the properties. I'm going to close the little properties tab. Or I could just tab over to program.cs, but I don't need properties tab for the rest of this assignment. Alrighty, we have a program here. All of this is boilerplate that got created when we created the project. Visual Studio added it all for us. Now, if you've taken a C++ class, you may remember, if you took it from me, that when we created an empty project, we didn't have any boilerplate at all, and we kept typing it in. This gives us some boilerplate, but it gives us a little bit too much. We don't need all of these using statements. In C++, we called them #include. In Java, we use import. In this language, they use the term using. We're going to delete all 4, everything except for the using system. There. That's just a little bit of cleanup. Would it have been necessary to do that? Would it work without it? Yeah, it would work just fine. But there's no reason to have additional libraries being imported that we don't want. Alrighty, I don't have this code memorized, so I have to go and pull back up the PDF. Oh, I am very sorry. I meant to zoom this in larger text. So what we did is we just deleted the using system lines. Excuse me, the using statements, other than the first one. So looking at the PDF, here we go. We're going to place some code between the curly braces that begin and end the main program. You see this code right here? Int n is equal to args.length and stuff like that. That's all the stuff that we need. I'm going to kind of see if I can get both of these on the screen at the same time without making things look really horrible. Let's just see if I can do that. Alrighty, maybe that's enough for me to get away with. Alrighty, so inside the main function, inside the body of code there, I'm going to declare an integer, n, which is going to be equal to the number of arguments. Now that we are using arrays. If you don't remember how to use arrays or you haven't used them yet, that's okay. We're just typing in code at this point, kind of trusting the force. We'll get to arrays if you haven't done them before. The command line arguments are stored in an array so that we could step through them. Okay, console.writeline, we're going to writeline a message. This takes the place of cout or system.out.print in Java. We're using console.writeline. Here we go, and we're going to do number of parameters is equal to, and I will zoom in on that in just a moment. Alrighty. Number of, and I'm going to change that to arguments because that's really what they are. In fact, it says args here. I need to retrain myself from saying parameters. Number of arguments is equal to, and then a curly brace, still inside the quotes, 0, and a closing curly brace. Now we're not done yet. We need to put on a comma. I'm going to go to the next line. Well, I'm going to put the comma here after the quote and then go to the next line. You can put it all in one line. Now I kind of wish I'd put it all on one line. I'm going to do that. Alrighty, there we go. That's what it's supposed to look like. console.writeline, and then there's a string here. The string includes this brace, 0 brace. What is that? That's a placeholder. This value, this variable, when we send it to the screen, is going to fill in this placeholder. Just like if you've used printf, or if you use the %sign in a Python print. What's a 0? Well, this is the first value that's going to be printed. Okay, now we need a for loop because we're going to step through all the arguments. The argument is an array, so we need a counter, or we could use a for each loop, but we're just going to use a counter. For int I is equal to 0, and the syntax is exactly the same as it is in C++ and Java. I is less than the number of arguments, I++, and inside that for loop, we need a body of code, so I put a brace, and it's going to be another Writeline statement. Console.out, excuse me, I slipped into Java there. Console.writeline, parentheses, and we want one little placeholder, so curly brace 0, curly brace, is equal to curly brace 1 in curly brace. I think I got that pretty close. Yep. Not really liking the way I did that here. I'm going to modify it a little bit. If you just follow the instructions, it's fine, but I'm going to modify it a little bit. I'm going to print out I here, and then I want to print out the array value at that index. So it's going to say 1 is equal to, or excuse me, it's going to start at 0. 0 is equal to this argument, 1 is equal to that argument, and so on. We are just about done. We're going to put a return statement at the bottom. So here's what we did. We added all this stuff. If there weren't any command line arguments, the for loop's not going to do anything because I will always be, will never be less than n. But we did add some command line arguments. Now let's build it. You can build it from over here into the little build menu. If you hover your cursor, you see build solution or build console application. Either one of those will work. Or you can choose build solution or rebuild solution from the build menu. Either one of them work. If you don't want to use these toolbars, that's fine. If you want to get rid of those toolbars, that's fine. There'll be times perhaps when I want us to re-enable the debug bar, even if you get rid of it. All right. I don't think I had any errors. I think it says successful. I want you to see what it looks like if there's an error, so I'm going to go into the for loop and remove one of the semicolons. Doesn't really matter. I'm just introducing a syntax error. Notice that now we have a little red underline there showing that there's a syntax error. I'm going to pretend I don't notice it, and I'm going to do a rebuild solution, and I get an error list. See the error list, the word error here? If you don't have that error list, if for some reason it got closed, you can find it under View, Error List, just like we had to do View Solution Explorer if the Solution Explorer gets closed. So View Error List, here it is. It said a semicolon expected. It even tells us what line number. Line number 11. That makes it real easy to zero in on it. I see line number 11. I see the I there. It's underlined. And doesn't tell us exactly what's wrong, but this does, this description. Sometimes it's more cryptic than this, but it was expecting a semicolon. So I'm going to put the semicolon back. Now, if you already had another error, then you may, you just have to recheck the PDF to try to figure out what's different. The only thing different between what I did and what the PDF shows is I had the word parameters here. And I don't just want to repeat the word parameters, so I'm going to leave it as I have made it here. But the PDF is fine as well. Let's run it. Notice the green start arrow. Maybe it's a different color on yours. Start. And boom, it disappeared. We didn't get to see the output. That is really annoying. I would think that by default it ought to keep the output window, but this is common to most languages. We need to stick a line of code in front of the return statement. That will let us get it to pause. Now in C++ we did a system parentheses pause. We're not going to do that. We're not going to make any calls to the underlying operating system. That doesn't work on Macs anyway. So let's find out what we do need to put in it. console.readline. So it's just going to sit there waiting for them to hit enter. And it's not going to even tell them that they're waiting to hit enter. We ought to print a message, you know. Console.writeline done. How about that? We're going to tack that on. Press enter. That's not on the PDF, but it's nice to let them know what they need to do. And then console.readline. This takes the place of using CIN in C++, the input statement in Python, or the scanner in Java. All right, let's run it again. Now it won't close the window. There's our window. Going to make it a little bit larger.
How is it getting it from the properties in our debug properties?
Right, so the question is how did these things, how did these words, how did these arguments get from the properties into the program? Well, when we build a program, it generates an exe. And then when we run the debugger tacks on these command line arguments after the exe, just like we were going to run it from the command prompt. You know what, I'm not sure that I named the application the right thing. It was supposed to be called CS_A, and I don't recall if I did that. No, I left it as program.cs. If you follow the instructions exactly, it should say CS_A for C# tutorial A. I don't really care. Be nice to have a consistent naming scheme though. So anyways, you know, if I was going to run the program, I would type program and then I would type some command line arguments. You know, my name is Slim Shady, whatever. And they would show up here. Instead, I set them in properties because I'm not running it from the command line myself. Visual Studio is. And we can see them. Notice that the things that were in quotes are multiple words. So something in quotes counts as a single command line argument. So the word Jar Jar Binks is a single command line argument. And then is the best, then Star Wars we also had in quotes. So both of those words are a single command line argument. Alrighty, I hope that made sense. The next thing we want to do is to take a screenshot and to upload a zip of the project.
Which I know how to do, so.
Okay, so if you read the instructions, you'll see that I really want you to upload two things. A screenshot of the program running. That way, you're proving that the program ran. If I can't get it to run, you still have the screenshot to prove that it ran on your machine. And a zip of the project. Finding the project files is always a little bit of a challenge. It's in a different place on every machine, but it won't be a problem. Okay, so let's get a screenshot of the program running. It looks like I closed it. I'm going to run it again. I'm going to click Start. There's my application. It's sitting there running. Now, how you take screenshots is entirely up to you, especially if you're on a different flavor computer than Windows. But on your keyboard, there should be a print screen button. Click the print screen button. And if you're using Windows 10 or 8 or something, it may automatically save that somewhere. Who cares? Instead, we just want to paste what we just supposedly print screened into a document. Because when you click that button, it places it into the buffer so that you can paste it. So you could either load up Paint or Word. Either one will work. Just load up Paint, Word, and then hit Control V for paste, or click that big paste button. You know how to paste. And there's our screenshot. You don't need to crop it or anything unless you just don't want me to see your toolbar or something like that. That's good enough. So I'm going to do a save and save this to a C# folder, which I apparently haven't made yet. So I'm going to go to my desktop, make a C# folder. New folder, CIT1713 C#. Then I'm going to go into that, and I'm going to save my PNG. Since it was the first tutorial, I'm going to call it cs_a.png. Now I have a screenshot file that I can upload. We also want the code itself. So let's just zip up the whole shebang. Let's get the whole project. So what I'm going to do is I'm going to close the solution. I'm going to click on the File menu, choose Close Solution. There. Everything's gone. I may as well even close Visual Studio because I'm done with it for now. But I need to go and find that project folder where all of these things are stored. Let's see if I remember where they are. I'm going to go and look in Documents. Visual Studio 2013. Alrighty, I'm going to open that up. Under Documents, Visual Studio, there's one called Projects, and it's not there. Alright, so I've made a mistake. I do not know where they're being stored. I'm going to pause the machine while I go and find them. Alright, to find out where they really are stored, I'm going to open that solution back up with the recent projects. So File, Recent Projects. I'm getting my solution again, which should have been called CS_A. Now I just need to find the properties of it, and the properties will tell me where the file is stored. Also, if I did a save as, it'd probably tell me. I've lost my Solution Explorer, so I'm going to do View, Solution Explorer. There's my Solution Explorer. I'm going to right-click on Solution, the line that says Solution. Right-click. Oh, well, there it is. There's Open Folder in File Explorer. So it turns out, okay, mine is in a different directory because I'm also doing C++ development, and I set the default folder for all projects to be C++. So anyways, there it is in mine. I'm going to bop back up a level so that I can get the entire project. There's our projects. Console Application 1 should have been called CSA. I'm not going to rename it here though. I'm just going to go ahead and run with it. So, to make a zip file, you do send to compressed zip folder. And here we could rename it easily, cs_a.zip. That's my zip file. If you're looking at it and it doesn't say .zip, you're going to want to enable file extensions. I'm going to show you how to do it in Windows 7, and I'm quite sure that it's different for Windows 8, Windows 10, whatever. So you may have to Google up Enable File Extensions Windows 10. But whatever, if you have the Explorer window open, you should be able to find something that says Folder Options. In my case, it's under an Organize menu. Folder and Search Options. You click on that, you click View, and one of the checkboxes is Hide Extensions for Known File Types. You do not want the file types hidden. So we're going to deselect that. If it was selected, then when I was looking at my files, they would have no file extensions, and I might upload the wrong file. So instead, I'm going to deselect the hide extensions, apply OK. So I want to get that CSA zip file up, and then I also want to get that screenshot up. I'm going to move my CSA.zip file into my C# folder so that they'll both be in the same place. Now when I go over there, I see my image file. I happen to make a PNG or bitmap or whatever, I don't care. Or if it's a Word doc, that's fine. And then the zip file, and I'm going to upload those into the Dropbox. I'm going to assume you know how to upload things into the Dropbox. So just go find the Tutorial A Dropbox in D2L and upload both those files. Alrighty, that concludes this lecture. Text me, call me, or phone me, email me if you have any questions. Alright guys, we're going to cover some of the Chapter 2 PowerPoint for C#, and we're going to do some tutorial stuff. The tutorial stuff is in the Dropbox. I believe it's Dropbox B. Let's get to the PowerPoint. Kind of skipping Chapter 1. You can read Chapter 1. In fact, I want you to read Chapter 1. Assume that it's a reading assignment. Hit the PowerPoint for it. Alrighty. So, a lot of this stuff is going to be reviewed because I am assuming that you've had prior classes about how you declare variables, display variable values, use arithmetic operators, that kind of stuff. So this chapter is going to be a breeze.
Oh, I did have a question from reading Chapter 1 though. I get confused because how it says there's no primitive data types in C#. So these are not primitive data types, but they do the same exact thing.
Exactly. In C#, as opposed to Java, there are no primitive data types. If you declare an int, it's actually a class. It's the equivalent of the integer uppercase wrapper class for Java.
Okay.
And, you know, the float uppercase F wrapper class and stuff like that. So you just not inherit, you just have some methods that you can call on this stuff. But when you need to use it, it's just treated as a pure double or a pure integer or whatever.
And is there a reason C# doesn't have primitive data type? Or is there, like, what was the point of excluding primitive data types? Do you know?
I think just to make everything a class, it's designed to be part of the .NET framework, and if everything is a class, you could make absolutely sure that the data types are compatible between different languages that adhere to the .NET framework. The question is, why didn't they make primitive data types? And since .NET is so focused on connectivity and talking to servers and stuff like that, if you make these things all classes, then the libraries that communicate, you know, online and stuff like that are already equipped to handle them.
Gotcha. Makes sense.
So we're going to have bool, true and false, character, which contains a single Unicode character, which is more than 8 bits wide, because Unicode needs to support, you know, Romanian and, you know, kanji and all sorts of character sets. Learn about the string data type, named constants, enumerations, and accepting console input. So what is a constant? It's something that cannot be changed after the program is compiled. So once you declare a constant, it's the same throughout the lifespan of the program. If you want to change that value, you have to re-edit, recompile your code. A literal constant. A literal constant, otherwise just known as a literal, is a number that you hardcode in it. If you type in 3.14, that's a literal constant. Or you can define a variable as a constant. A variable is a named location in memory that has a type and can contain different values. I've said that in all my classes. I'll repeat it here. A variable is a named location in computer memory that can hold different values and has a type. When it says different values, a constant, if you have a constant variable, it's not going to be holding different values. It's kind of an odd way of writing it. So the data type describes the format and, incidentally, the size, the amount of memory occupied by that data item. So there are intrinsic types. Intrinsic types kind of are like the primitive data types in Java, but not really, because everything in C# is a class, including data. So you have your built-in data types. These are aliases for names in the system namespace, which we'll learn about that. And all of the built-in types are called simple types, except for string. So I guess we're going to call them simple types from now on. And Unicode is the system that provides a numeric value for every character. So an A is a Unicode 65, and a capital B is a Unicode 66. The ASCII character set that you may have learned in another class is a subset of Unicode. All right, all the different data types. Are we going to use all of these? No. A byte is an unsigned 8-bit value that can go between 0 and 255. An S byte is a signed byte. So if you're used to programming in Java or whatever, this looks like dramatic overkill. Why do I need so many different types? Well, you're probably not going to use all these. But if you ever need an unsigned 32-bit integer, you can get one, as opposed to a signed 64-bit integer. What's the difference between an unsigned integer and a signed integer? Well, say you have an 8-bit value, 0000 all the way up to 1111. Or excuse me, 8 zeros as opposed to 8 ones. This gives you a range of 0 to 255. And if you don't know the binary, how that gives you those values, that's okay. Just trust me on that. 8 bits is equal to 256 different values from 0 to 255. That's for unsigned. It can't go negative. Signed means that the first bit is reserved to indicate whether the value is positive or negative. A 0 in the first bit means it's a positive. A 1 in the first bit means it's a negative number. Now I'm actually going to give you some incorrect information here because I'm not going to take the time to talk about 2's complement. But this is almost the way it works. If you have that that's equal to 127 in decimal. That's the highest positive value that 8 bits can contain with a signed bit. Why? Because we don't have this bit anymore to play with, and this bit is equal to 128, almost called it 128 points like it was a game. The value 128, which would get you all the way up to 255. And then you have all the negative numbers, from 0, 0, 0 all the way out to 1, 1, 1, 1, 1, 1, 1. And so since that bit has been flipped, that would indicate that it's equal to a negative 127. Now that's what I said was not strictly true. It's not equal to 127. And the reason for that is you would not want this to equal negative 0. There's no such thing as negative 0. So instead they use what's known as 2's complement. The maximum value of a signed byte is 127. The maximum negative value is negative 128. So, like that. Not going to show you why. So, signed bits, the value can only go half as high, right? From 0 up to 127, but you also have all the negative versions of those. Still add up to 256 total different values. If you take the difference between 127 and a positive 28, it ought to be 256 different values? Not looking like that. Okay, maybe. Anyways, so you cut in half the total range. You make half of them positive. You make half of them negative. So that's the difference between signed and unsigned. And we have signed and unsigned of all these different types. You have signed ints. You have unsigned ints. You have signed longs. You just leave the S off. You have unsigned longs. The maximum value of an int is about 2 billion. The maximum value of an unsigned int is about 4 billion. I said long and I typed in. The maximum value of a long is much larger. We can see all of these over here. 9 to the power of 10 to the 18. 9e to the 18. So that would mean that the unsigned int could hold larger values. 1.8e to the 19. Something like that.
So you couldn't get, okay, so if you wanted a number, a signed number less than negative 128, like you wanted a negative 129, it would have to be a long?
Well, it wouldn't have to be a long, but it'd have to be, your hierarchy is that you have bytes, which are 8 bits, 256 different values, and then you have ints, which are 32 bits, which can go up to 4 billion different values. And then you have longs, which are 64-bit values, which can go up to 1.8 e to the 19 different values. And it looks like we're missing 16. Let's go look at our PowerPoint. 16-bit version. Shorts. Okay. So we have shorts. And all of these are defined in C++ as well. It's just that C and C++ have grown up on so many different architectures that they're not fixed in length. You don't know that a short is equal to 16 and an int is equal to a 32. In Visual Studio and Microsoft C, they're set up a specific way. You will see that in C++, a float and a double, an int and a long are actually the same number of bits, which is absurd. And then if you want to use a larger value than a long or an int, you have to use long. But that's C++. In C#, they were starting fresh, creating their Java type language, their clone, their competitor to Java, and so they were able to specify everything that they want. So a short 16-bit value can contain up to 65535 different values if these are unsigned. So an unsigned byte, an unsigned short, an unsigned int, and then what? Oh, okay, go away. Alrighty, so 6553, 6 different values. And if you're using the signed version of those, which you get just by leaving off the U's, then you could only go up half as high, 127 for a signed byte, 327 whatever, half of that for a signed short, 2 billion for a signed int, 9e to the 18 for a signed. So if I was going to ask on a quiz question something like that, I wouldn't ask you to specifically recount these, but I might say, what is the smallest? Or if you were going to hold only numbers, between 0 and 64, which would be better? A long or a byte, and a byte would be better if you're going to only hold values between 0 and 254 or 64, whatever I said. If you're going to hold huge numbers larger than 2 billion, 4 billion, you'd want to use a long. So characters are actually 2 bytes long rather than 1 byte. ASCII characters are 1 byte, but Unicode characters are 2 bytes. They're underneath it all, they're just an unsigned int that hold a number, but each integer corresponds to another character in the Unicode character set. A Boolean is a 1 byte value, but all it can do is represent a true or false. A string is a collection of Unicode characters of 0 or more length. And then there's a class called object. Every object in class, every data type, everything in C# inherits from the object class. So to declare a variable, just like in almost every other language you probably have studied recently, you give the variable type, you give the name, and then if you want to, you can initialize it with a value. If you feel like creating multiples in the same time, you can do that. My age is equal to 24. My weight is equal to 75. I'm either pretty small or that's not in pounds. Okay. So you can define multiple variables in the same type in a single statement, or you can separate them in separate lines. Int x is equal to 3, int y is equal to 4, like that. And of course, these are supposed to be lowercase. The equal sign is known as the assignment operator. The associativity is right to left. So, this value gets copied in to my age. If you want to, you can write silly statements like this. X is equal to y is equal to z is equal to 100. And that copies 100 into z, which gets copied into y, which gets copied into x. You feel like assigning a whole bunch of values in one fell swoop, you can do it that way. So if you assign the variable when you create it, that's known as initialization. Otherwise, it's known as an assignment. Why make the distinction that? Is initialization. It's just what happens when you declare the variable. And then later on, you can change its value via an assignment. So here's how we could display something, display a variable. There's a method called Writeline. Well, I thought it was called system.console.writeline. Notice the using statement. Just like in C++ where you can use a namespace, we can use a namespace here, and the system.console namespace has the method Writeline in it. So by using that namespace, we can shorten our function calls. We don't have to type system.console.writeline. We can just say Writeline. That helps. I don't really mind typing system.console myself, but if you like typing quickly and choosing from lists of things, well, if you like typing quickly, do the using. If you don't mind specifying it, you like fully qualified method names, then don't do that and just type the whole thing out. So here we've created a variable called sum money. It's a double, which means it's floating point. It's not an integer. So that we can have a decimal point in here. Writeline, we write it out. It prints out 39.45. So here they use 2 write statements. Write without the word line after it doesn't go to the next line. So it says the money is $. The money is $, but since they just called write, it doesn't go to the next line. And then they use Writeline to print out the rest of the value, and it would go to the end of the next line. Just like the difference between print and println in Java. So a format string. A format string is something that you can send to the write or the Writeline method that can contain fixed text and also placeholders. The placeholders get filled in by variable values as it's working, as it's being sent to the screen. And we illustrated this in the last tutorial. So the placeholder consists of a pair of curly braces containing a number. And that number specifies the desired variable's position. So if you do this, Writeline, the quote's wrong because I'm using a Microsoft editor. You know, %1, %2, %3, and then I send 3 values to it, 100, 200, 300. It's going to print 100, 200, 300. And yeah, sure, why didn't I just print 100, 200, 300? Because we can embed some text in here. You know, number 1, age 2, you know, weight 3. And when that ran, it would say number 100, age 200, weight 300. Now these numbers, you can mess with them if you want. You could say, I'm going to print out that placeholder. I'm going to print out the 300 as my first number. And then I'm going to print the first number out as my second value. And then I'm going to print my second value out as the last one. That's confusing, but okay. So the third value in our sequence of parameters passed into it is 300. So that gets filled in here. Our number is now 300. What is our age? Well, it's the first parameter being passed in, which is 100.
Does it not start at 0?
Does it? It probably does.
Program we did,
It starts with 0. Okay, I goofed that completely. All right, I'm going to pretend that, there we go.
That works.
All right, anyways, I should have demoed, you know, a %0 as well. My mistake. Please remember that there's a 0 placeholder as well. Do not make the fatal mistake I made, or else you'll get an error when you try to run it. So this one's just never going to get printed. That 0 is never going to get printed because there's no placeholder with the number 0 in it. Hope that makes sense about how the numbers don't have to be in the same order. That's different from Python and C++ and Java. If you want to skip one entirely, you can. We skipped placeholder 0, you know. Now, why would we put more data here than we're going to print out? I don't know, but you can. You get to specify which placeholders you want filled in, or which values fill them in. So the value is $0 exactly. So this is our string right here, and then the placeholder is part of it. So we only need one print statement rather than two. On the last one, we did a write, the money is $, and then we used a second print in order to get the value. With the placeholder, with the formatted printing, we were able to specify where the value was going to be inserted into the string. Then this string gets printed out with that parameter filling in the 0. And you can apply additional formatting. If you want it to be left justified, you can do that. If you want it to be right justified, you can do that. If you want it to have a certain number of decimal places, if it's a floating point type, you can do that. All right, so here we display three different variables. We write a 4, we write a 56, we write out a 789. And so that prints out 4, 5, 6, 7, 8, 9. We could have printed that out easily without the use of placeholders, so I'm not sure why that's the most awesome. Oh, because of this example up here. I have placeholder 0, placeholder 0, placeholder 0. This is interesting because C++ and Java and the other languages do not allow you to use the same placeholder over and over and over. Whereas here we're saying I'm going to print out this parameter and it's going to go there. It's also going to go in there and it's also going to go in there. More examples. Here they have not only a placeholder, but whether it goes to the left or to the right, if you leave off the minus sign in the width, that means you want it left justified. Oh, sorry. If you leave off the minus sign, since there's no 0 there, I did not mean to launch the editor. Are you going to pop open an editor? No. Okay. So this says 0, 5. That means fill in parameter 0, which goes there, and I want you to format it to be 5 spaces. And if we look down here, it is formatted to 5 spaces. It's got 4 leading blanks followed by a 5. If you want the blanks to trail it rather than to lead it, you can left justify it with the minus sign. That means that the trailing blanks will be used rather than leading blanks. So here we're going to print out Richard Lee. And we're going to say that parameter 0 is 8 spaces wide and we want it left justified. parameter 1 is also 8 spaces wide, and the minus means left justified. Why is that important? Well, if we didn't do that, then they would be lined up like this, based on the right side. It would say Richard, Martian, Ed, and they would all be lined up on the right margin rather than the left. So numbers look pretty good, right justified. But names, we tend to like to see left justified. The integer data types, integral data types, store whole numbers. Byte, signed byte. I think I have goofed by saying that there was something called a unsigned byte. I think byte by default is unsigned, and so they specified a signed byte. As opposed to the other ones, you have short, the 16-bit type, and unsigned short. You have int and unsigned int, the 32-bit type. Long and unlong, unsigned long, ulong, and then the character. They hold integers, hold numbers. Floating point numbers contain decimal positions. Specifically, they have a specific number of significant digits, which indicates the mathematical accuracy of the value. A float is accurate up to 7 significant digits of accuracy. A double, and they support a certain size. Oh, my brain just froze. You have the exponent, but there's a more specific term for the exponent. Anyways, you have a certain size, a certain number of bits dedicated to the mantissa and then to the exponent. The mantissa being the number in front, of scientific notation. So a float can hold a number, but it's not super precise. It's only precise out to, like 0.1234567. If you typed in 0.1234567891111, it would lose the rest of it. None of that stuff would be there when you printed it back out or performed a calculation. It can only hold 7 significant digits. I hope you have the idea of significant digits. Anything past that gets rounded off. A double, more bits, so it can hold many more significant digits of accuracy. That is why so the mantissa can be more precise and the exponent can be more precise. So if we go back here, a double can go out to 1.8 to the power of 308, so it can hold a much larger exponent as well as being more precise, whereas a float can hold a 3.4 exponent 38, a smaller value. So yeah, this number would be large enough to hold, the debt of the United States, which is just in the trillions, not in the super duper quazillions or whatever, 38 is. But if you need an astronomically larger number, then you'd use a double. I don't mind just using double all the time, to be honest. Then there's a decimal data type, suitable for financial and monetary calculations. The idea behind the decimal data type is it's not supposed to give you rounding errors. Floating point types do give you rounding errors. We could demonstrate one where we divide something by 3 and then multiply it by 3 and it's no longer the same number. I'm not sure if 3 is the magic number for actually getting that to work. But, due to the fact that we represent numbers in decimal and these numbers are converted to binary, then when you convert into the binary, they may not convert exactly, either to, the number of places that a float or a double can hold. So the decimal data type is good for money because it's not supposed to exhibit rounding errors. And it can have 29 significant digits. That's a lot of money. Of course, it can be used for other things other than money. If you want to declare a literal to be a float, you put an F after it. So if I wanted to say float temperature is equal to 98.6, I put that F there. Why do I put that F there? Because otherwise it assumes it's a double. This is common to Java and C# as well, I believe. If it's a double, you can put a D after it. But literals are declared as double by default. If you want it to be a decimal value, you put an M after it, like money. That specifies it to be a decimal value. If you want to use scientific notation, you use a capital E. So C# displays floating point numbers in the most concise way possible while maintaining the correct value. Meaning that if the value of it is equal to 3.54 and you print it out, it prints out 3.54 rather than 3.54 followed by, 6 zeros or whatever. But you can specify the precision that you want to display it, how many decimal points you want. And I'm sure there are examples of that in just a little bit. Format characters. We have lots of formatting characters. You want to print out a currency, you use a C. You want to print out a decimal value, you use a D. If you want it to be formatted for exponents, E. F is fixed point, where it doesn't slip over into using exponents. G is for any kind of number, and it'll flip-flop from displaying integers or floating point numbers as scientific as it needs to. P is a percent, so it just shifts the decimal point over 2 for you to pretend, because if you have 50%, it's really equal to 0.5, but if you printed it out as percent, it would display it as 50. So you don't have to multiply by 100 as you print it out. Round trip, I do not recall what that does, ensures that numbers converted to strings will have the same values if they are converted back to numbers. And then if you want to print something as a hexadecimal value, you can force it to do that. Is it going to give us any examples of that? No, we just blaze on to arithmetic operators. So why don't we Google up some good examples? C# formatting for floating point. Formatting a float to 2 decimal places. You pass a format into the toString method. That seems like odd. I wouldn't want to have to do it that way. Here we go. Here's the formatting string. Placeholder 0, and here's the format. We want it to be filled in up to a maximum of 2 decimal places. I think it's about time to actually crank up a C# file so that we can play with a couple of these things. So I'm going to launch my version of Visual Studio, which I'm fairly certain is different than yours, but through our last tutorial I became convinced that they're fairly similar as far as C# development is concerned. File, new, project. C# console application. And I think we're going to stop lecturing on this and do a Windows-based application as well, as long as Visual Studio 2017 supports Wpf application. We'll find out real soon. Alrighty, now we're into it. I'm going to declare a double. I'm just going to give it the creative name of D, and it's going to equal 1.234567889. Now I'm going to print it out. Can't I use console.writeline, and inside my quotes I'm going to put this special formatting string, brace 0, so that it'll be filled in with that value, followed by a number sign, comma, a couple more number signs, decimal point. When I say a couple, I meant 3. And then 2 more number signs. Let's see what that prints. And it displayed it and disappeared entirely. So system.console.readline. We're just going to make them hit enter. Or, we're going to keep it on the screen until they hit enter or close the window. All right, and so it displayed 1.23 right there. So blowing up the size to make it visible. There we go. So it displayed 1.23. I'm going to change that value. Not going to be 1.23. It's going to be 987. Oops, changes are not allowed while the code is running. Okay. So I need to close that app. I'm going to close it. I'm going to change this to be 987. Still not letting me change it. Didn't I? Okay. 9876.2345678.9. So when I run this, we see it's formatted like that. 9,876.23. So we saw that it rounded to 2 places after the decimal place, and then it formatted, up to the comma like that. What happens if we make it much, much, much larger than that? Well, we really only have, 7 or 8 different places of precision. No, it's a double. We could go 15 different. So 1, 2, yeah, change is not allowed while code is running. 1, 2, 3, 4, 9876 dot. What I'm curious about is whether it's going to continue putting commas as we go along. Let's find out. And it did. This was enough to specify that we wanted to put the comma in the millions place and the billions place and so on. So that's an example of a more sophisticated formatting, which is good for printing tables. If you're printing out a table, you want everything lined up nicely. You want it rounded off to the same number. Maybe you want commas, to represent thousands and millions and stuff like that to make it easier to read. So that's really about enough of that. We're going to go to the tutorial now. I want to find out if Windows 2017 supports Wpf applications. We'll find out real soon. So if you go to the Dropbox, there's a tutorial. As we go along, if it says C short assignment 2 or whatever, ignore that number because I'm giving the assignments in a different order than in the past, and subsequent to this assignment being created and all the rest of these, I've gone to naming the tutorials B, C, D, with letters or whatever. Well, I believe this one's actually B. Just kind of ignore that. Or I could take those off entirely. That would probably be best. You can tell from the file name which one it is. Okay, so what are we going to do? Enter, edit, and test a short program. This lesson focuses on data types and arithmetic operators. So we can do this assignment one of 2 ways, either as a console application or as a WPF, Windows Presentation Foundation graphical application. If you want to do a console application, skip to step 10. Do we want to do that? No, we want to make a GUI application. So here's what I'm hoping Windows 2017 works. Supports.
Where is that file? Is it in your Dropbox?
So let's see. If we go to the Dropbox, I hope it's there. If it's not, then I will upload it. Helps if I'm in the right year. C sharp, C sharp, C sharp. Come on. It may not be there. WPF application, are you there? Are you not there? You're not there. Probably because I wasn't sure if I was going to edit it or not, if this didn't support WPF or not. But let's go ahead and get one there anyways, and then I can replace it if need be. refresh, make sure it's there, please.
It is indeed there.
All right. All right, so C# assignment B. We're going to try creating a WPF application. Launch Visual Studio. We can do that. Since I had Visual Studio open already to do this printing, I'm just going to close that solution. File, close solution. Yes, I want to stop debugging. Go away. It'd be kind of neat if Visual Studio maintained a list of projects that are currently open. Maybe there's a window that at least presents that, but it doesn't. So, as far as I know, File, New Project. What we want to choose is one of the C# applications. Under Windows Desktop, we want to choose Windows Form, WPF application. Come back. Okay. So I'm going to choose WPF application. I'm going to give it a better name than WPF application 1. I'm going to call it WPF short B. WPF to indicate that it is in fact a Windows Presentation Foundation. It's one of several ways you can make a GUI application using C#. So it's going to churn a little time. Here we go. Loading the designer. You can continue working while the designer is loading in the background. Well, we can't because we want the designer. This is the designer. If you've ever used a NetBeans designer, you'll be used to the idea here. We're going to be dragging buttons and stuff onto the designer, and then we're going to encode behavior for those buttons. You click on the button, something happens. So we need to find the toolbox vertical tab on the far left. It should be the first vertical tab under the toolbars at the top. If we can't find it, choose Toolbox from the View menu. So, View, Toolbox. Now I have the toolbox. I wish it was pinned, so I'm going to try to pin it. There we go. We will see here, and I'm sorry that I can't zoom in more closely, that we have common WPF controls and all WPF controls. Let's click Open the little triangle for common WPF controls. We have buttons. Buttons are cool. Labels. Labels represent text. Images, if we want some images on there. Text boxes for typing stuff in. So we're going to select the button control and drag it onto our main window. Button, drag and drop. Now we actually have a button. If we right click on it, can we change the info about it? Edit the text? Yes. Say I don't want it to be called button. I could call it something else. So then after I've dropped the button down, I can double click it and it will bring me to the source code editor. So I can edit what happens when that button is clicked. So if you notice, down here it's showing all the XML. You can change stuff here. You want the button text to be larger. You don't want it to say button anymore. You want it to say something else. You can edit directly the XML down here. You want to make it say my button instead. You can do that. I changed my button and it changed it right there. So anyways, I have the button here. I'm going to double click on it. That creates a method in my main class. You notice this looks considerably different than the other main class that we've created. It's because C# and the WPF form editor have created an awful lot of boilerplate that we don't see. But we have a main window. The main window is the one that gets created when the application is run. Very first thing it does is call initialize component. And now we just added a method that is called when the button is clicked. Position your cursor within the curly braces and get ready to put some code here. Now skip to the next page. Okay, if creating a console application, well, we don't want to do that. Let's go on down. Add these lines to the button one click method. Looks like we're creating a couple of variables and a string and a character. See if I can dock that on one side, Visual Studio on the next. Get my editor open. Zoom in. Yay. Alright. So down here under button click. 3 ints. Int I, comma j, comma k. Not k1, k semicolon. And then a string, string s. Unlike Java, lowercase s for string. Why is it putting little marks on here as I go along? Because these variables have been created but they're never used. If you hover over the int, it says it's a 32-bit signed integer. So the editor is giving us a lot of information about these things.
It's already going to give us an error because you're trying to assign a double to into an int, so it's going to give you an error.
You're right, that is going to give us an error. Yeah, so if we go down and we type in the code as given, we'll notice at point 14 there are errors in the above code. We need to fix all of these errors. So, you're a faster typer than I am. Char C, here we go. I is equal to J is equal to K is equal to 1.0. Why is this an error? Because these are integer types. And unlike C, C++, it will not automatically convert between floats, rounding them down to be integers.
And is that because they're primitive? I mean, they're not primitive data types?
Right, right.
You can't use, oh, okay, gotcha.
Yeah, so since these are not primitive data types, I don't even know if that's a fair statement because ints and floats and doubles and all that are primitive data types in Java, and it still complains if you try to copy a float into an int, whereas C++ is happy to do it and round it down. Okay, so S is equal to hello with apostrophes rather than double quotes. That's also an error. And then C is equal to double quote C semicolon. Now, since C is a character, it can only contain one letter, whereas string is a string, so it can contain, you know, either no characters at all or 20 or 100 or 100,000. All right, let's actually fix these before we go on. It's bugging me that these fix. So I'm kind of skipping down to point 14 where it says correct the errors until you can build the application. I can't build it yet. If I go to build, rebuild solution, and then I scroll down here, I get 4 errors. Cannot convert double to an int. It offers, you know, some hints. Are you missing a cast? No, I don't want to cast it. I just want to make this 1. So now it says I is equal to J is equal to K is equal to 1. I fixed that. What's the next error? Well, if you declare string, you have to use double quotes, not single quotes. And in contrast, if you are assigning a character rather than a string, you have to use apostrophe, single quotes. So I'm going to put double quotes around hello, single quotes around the C, apostrophes around the C. All right, then it does some math. It's got a modulus in there. Hopefully you remember what a modulus is. And it's got some addition and multiplication and stuff like that. You know what? I'm going to skip the math portion of it, and we're going to go straight to the string format. So, S is equal to, because S is our string up here, string.format, and we're going to use the same kind of placeholders that we can with Writeline. And here it is. I is equal to placeholder 0, J is equal to 1, K is equal to 2, and we pass in I, J, and K. I think at this point I can zoom it back out. Alrighty. So, let me use my double quotes here. I is equal to placeholder 0, curly braces. J is equal to placeholder 1. K is equal to placeholder 2. And now I'm going to type in I, J, and K as parameters. I, comma, J, comma, K. I could put them on the next line if I thought it looked prettier like that. The instructions don't show that. Oh, and a semicolon, of course, to end things off. Alrighty, we've built a string, but now we need to display it. Say we wanted to add something else to our string, some writing. I'm going to add something to it. This isn't part of the written tutorial, but so s plus equals, meaning we're adding something to it, \n, followed by the words I love C#. All right, hope that's clear. Backslash is, of course, the slash above the enter key, not below the question mark. And then I love C#, exclamation mark. All right, now we need to print it out. We've already seen how we could print it out on the console. We could type system.out.println. Whoops, not out of memory. Not system.out. System.console.writeline. I almost slipped into Java there. You know, S. That would print it out if we were creating a console app. But I'm going to comment that out because I don't want a console app. We're making a Windows-based app, a graphical user interface. So we're going to use a different statement. We're going to use messagebox.show. What that'll do is it'll pop up a little dialog with an OK button and our message. So message with a capital M, box with a capital B, dot, show with a capital S, and notice that unlike Java, the C# developers decided that methods begin with uppercase letters. So dot format is an uppercase, dot show. If you're a Java editor, I'm a Java programmer, that may annoy you because you've been taught all along that all variable names and all methods started with the lowercase letters. Anyways, dot show, and what are we printing out? We're printing out that string we declared. Alrighty. Now I'm going to run it. Here's my whole thing. Let me get the whole application back on screen. If I can. I'm going to put that IJK back on the same line. There we go, kind of. It's in our button click method, which we created by double clicking on the button in the editor. Int IJK, string S, character C. We never printed out the character, so it's got the green underline. It's assigned but never used. We could delete it, but whatever. We build a string format, we concatenate some additional text to it, and we call messagebox.show. So build solution. Hopefully there are no errors. Show the output from the build. Error list. Variable C is assigned. Well, that's actually a warning, so I'm not too worried about that. All right. I never saw a message saying that it completed or whatever. I must not have that window open. Click Start, and here it goes. It opens up. It says Main Window. We could change the name of that. We could edit the XML, or we could find a place in Properties to change it. I'm going to click My button. And it says I is equal to 1, J is equal to 1, K is equal to 1, and on the next line it says I love C#. All right, I'm going to click OK. And then when I want my application to terminate, I click the red X. And I know that writing was far too small for you to read. That's why I read it aloud. I is equal to 1, J is equal to 1, K is equal to 1, I love C#. And if you're following the debug, the instructions, you could go ahead and put in the math statements that were in there. So the homework based on this. All right, if you know what a limerick is, write a single line comment is // a multi-line comment is /*, just like in Java and C++. Write or create a Wpf application that will display a limerick using the message box dot show function. What is a limerick? It's 5 lines of code. I'm going to look up a sample limerick. I'm going to go over here, limerick. Some of them are, you know, not G-rated. I'm going to try to find a G-rated child's limerick, you know. All right, there once was a lady named Sue who had nothing whatever to do, and who did it so badly, I thought she would gladly have stopped before she was through. Now that's real boring as a poem. There once was an ape in a zoo who looked out through the bars and saw you. Do you think it's fair to give poor apes a scare? I think it's a mean thing to do. All right, yeah, whatever. Okay. So, here is an example of a limerick. You can just use this. Or, better yet, use your own. Make your own. All right, so there's our limerick, right? I want you to actually include, I actually want it to be 5 lines of text. I don't just want 1 line of text that goes on for, 200 characters. What does that mean? You're going to wind up using /ns, right? So use /ns for the line breaks so the message is not just one long line. All right, so that's the homework. Create a limerick program. I suppose I could also ask you to do it as a console application, but hopefully by now you've created a console application and you don't need to do it. All right, I hope that's clear. I will upload the instructions. I need you to zip this folder. So let's do that.
When you're uploading it, it gives you the option to zip it from there.
While you're uploading it?
Yeah.
Yeah, you can upload it. You can zip it while you're uploading it. So let's go to the Dropbox. Choose the Wpf application folder. Click Add File and go to where our Visual Studio files are stored. In my case, I believe they're not in Documents. I think I moved the default folder. You probably find them under Documents. I moved them to a C folder. And then I have one called Wpf Short B. Whatever you called your project, it is. I'm going to close Visual Studio so that it has no problem zipping it. So I'm just closing Visual Studio before I even upload it. Then I'm going to right-click on Wpf Short B or whatever you called it and do Send to Compressed Zipped Folder. That makes a zip file. If you have not enabled extensions, I recommend you do that. Upload that zip file. Just click Open, Add, and Submit. And I need to post a 2-minute long tutorial about how to enable file extensions on Windows 10 as well as what you've seen here in Windows 7 because it looks a little bit different. Hopefully not too hard. You can Google it yourself. File extensions Windows 10. It's nice to do that so that you can see the difference between the .cs files and the .zip files, and everything else just by their file name. Not that teeny tiny little icon. All right. That is the end of the tutorial, and that is the homework assignment. I'll create a Dropbox for the homework assignment, and you can have fun with it.